So hi guys, I'm back with another video. So in this video we are going to see about Kafka ordering system implemented using Golang. So this is the GitHub README page where you can see the source code which is available. Here I will drop the link below. And we are going to implement this lightweight event-driven order processing system both using Go and Apache Kafka. So I've seen a lot of videos implementing Kafka using Golang, but I haven't seen any videos that go in depth about how we can actually improve that system. So here I've given this project structure which I have implemented using Golang, but you can extend this project into a microservice architecture one to a real-world project using this particular project structure over here. So basically, if you understand what I'm going to tell you in this video, you can easily implement Kafka in any of their projects. So this is the processing systems GitHub page. So let's see the working of this. So this is the code. So mainly we are going to create consumer, producer, and the broker, which is Kafka, for an ordering system. So let me just go to the localhost here. So this is the UI of this system. So basically you're going to type the product out in the space. So let me just type until heavy here and increase the quantities and place the order. The order is placed here, and in our system we can see that the order, the producer sent the message and the consumer was already listening to it, and we get the order received as Jalebi 3. So this is what we are going to implement today in this project. It's a web server design thing. So basically I've used HTML, CSS. I haven't used CSS here, only HTML. So yeah, so this is what we're going to implement. As you can see here, neat architecture, and we are using Docker Compose for running Kafka. So here we are having some little bit of stops that we need to learn before connecting Kafka to our local host. So the local host of the web page is running in my Mac, and Kafka is running in Docker. So we should be careful about how we are connecting this, because I got a lot of bugs here before connecting Kafka. So this is the system that we are going to implement here, just a basic ordering system. So before getting into all that, let me just give you guys an intro about Kafka. So yeah, so what is Kafka? Kafka is a distributed streaming platform. Basically, that means we can publish, subscribe, and do analytics on the streaming data. You can store the data which is in the form of stream messages. That's it. That's Kafka. For giving you a simple intro, I've got an example for you guys here. So basically, Kafka got three main things, which is producer, broker, and the consumer. So the broker here is our Kafka. So let me just take a real life example here. So you got a friend who is living in USA, and this guy wants to send a package to another guy who is living in India. So in traditional systems without any international courier platforms, this guy has to travel all the way from USA to India to hand over the gift, the parcel, to his friend, which is, I know, it's a tedious process. So he got to find a flight, he had to book the ticket, and if any of the system goes down, the main thing, which is sending the parcel to his friend, the main process won't occur, right? So that's where Kafka comes in. So the broker here is the international courier platform. So this guy has to send the package to the international courier service, and that's it. He can just forget about that package because he knows that the package is gonna safely go to his friend in India. That's what Kafka does. So here the friend in USA is a service. Let's say it's ordering service, and we get a package. So let's say that the package contains, from our previous example in our project, the product, which is I think jalebi, and the quantity, which is 3. And this ordering service wants to send this one to the packaging service, which is the consumer here. Let's say that packaging service is the consumer here. Instead of directly communicating with the packaging service, the ordering service can send this data, the event, into this broker, which is the Kafka queue. So from that, our consumer can easily access it. So no direct communication between producer and consumer, just we got a broker. You once send that package to a broker, that's it. You don't have to just always remember about what I've sent or what's in that, nothing. You just send that and it will be safely handled. That's how Kafka works. So let me just move on to the architecture of Kafka. So these are producers here. The producers can be of many services. It could be an ordering service, an inventory service, or a packaging service. So any service, it can be of any service. And the broker here, so Kafka can have many brokers, which means you can have multiple server brokers. But let's just say that this server works on 9092. We can have another broker which can work on another server called 9093, and another broker called 9094. So these brokers are distributed across different servers for scalability purposes. So it's not just like that you got to have one broker, you can have multiple brokers. So each broker is going to have a specific topics. So topic represents a queue, just like that. So each topic is going to have a queue. So in this queue, let me just say that we got a parcel with the event from the ordering service. It's going to enter into the queue of this topic called orders. And let me just say that a consumer, we also got a consumer of analytics, and also let me just say that inventory is also a consumer, and packaging is also another consumer. So when these consumers subscribe to this topic, this ordering queue is going to send that particular package to all these consumers here. You can see that all these consumers here. So basically what's happening here is that we got a topic which is known as orders. So each time the producer produces an event, that event is going to send it to this topic, and this topic is going to distribute all that to the consumers who have subscribed to that particular topic. That's what's happening in topic. Then you may ask why we are having these partitions. These partitions are for the scalability purposes. Let's say that you have, from the previous example, you got a friend who is sending from USA. So in the first partition, which is multiple queues, in the first partition you can just say that these are the parcels that's going to come from USA, and the second partition you can say that these are the parcels that's going to come from India, these are the parcels that's going to come from Israel or something. Okay, so these partitions helps in improving the scalability of sending the parcels, sending the events to different consumers that are subscribed to our system. So this is the basic idea of Kafka. So the main thing about Zookeeper in Kafka is that we have multiple brokers, but we can only create topics from that brokers who are the leader of this particular Kafka cluster. So let me just erase everything, and okay. Let's just say that we got this broker as our leader. Only this broker can create multiple topics, okay, for multiple topics for multiple brokers, and it can organize the multiple brokers. That's what Zookeeper does. Zookeeper helps in maintaining the leader brokers of the Kafka cluster. So yeah, I think I've covered Kafka and Zookeeper and everything. So this is the basic idea, guys. So from this, let me just move on to our code. So how we can implement Kafka using Golang. So yes, guys, let's get into our coding part. So this is our main directory called Kafka, and we're going to make the subdirectories called cmd, internal, and the web. So let me just clear that, and inside the cmd I'm going to create another folder called API, and inside API I'm going to create this Go file called main.go for accessing our web page, and inside internal I'm going to create the make directory functions for order. So inside order, let me just move on to order because I can't just create new file every time. Internal and order, let me just create using touch function. So what are the files that we are going to create is consumer.go, and then producer.go, and then another file called handler.go and model.go, and the next one is handler. I think I already made handler. Consumer, producer, handler, model, and yeah, the main important thing, create topic.go. Yes, these are the files, and let me just move on to the home directory. Oh, sorry. Let me just move on to the home one, and then what we're going to do is we're going to go to the web, and we're going to create another file for our HTML page, which is index.html. Yeah. And after this, we're going to initialize the project using go mod init Kafka Go, yeah. And then we are going to get a library from GitHub Segmentio called Kafka for implementing all the Kafka functions. So let me just copy paste that GitHub library from my GitHub repo. Yes. Yeah, we are good to go. So before getting into all this, let me just implement the create topic function. So the package is going to be order. So using this create topic function, we're going to create a topic called order, which is going to be subscribed by a producer and the consumer for delivering the order. So for our create topic function, we are going to need this following libraries, which are import log for logging, and then fmt for printing, and then our GitHub Segmentio page library. So let me just create a function called create topic, and then yeah. So for the create topic, we are going to create a connection for our Kafka, which is running on the localhost 29092, which will be implemented in the Docker Compose file. So let me just go on and implement the connection error, and the Kafka using Kafka function from the library. We are going to implement Kafka dial. And inside the dial, we're going to need a network, which is going to be TCP, and what is requiring the address of that particular Kafka location, which is 29092. Yes, so let me just handle the error. If the error is not equal to nil, let me just log out the error. Yes, this is the connection, guys, for implementing Kafka. And then we are going to do a controller. So using this controller, we are going to get the main leader broker of the particular Kafka cluster. So from that leader broker, we are going to implement our topic, because in the definition part, I said that the leader broker is the only broker which can create topics. So let me just go on and create we can get the controller broker from using controller. Let me just create a variable called controller, and from that we are going to get con.controller for getting the controller broker. And again, if there is an error, you can just copy paste it right over here. And then we are going to get the controller, the connection of that particular broker, which means the port and the host name of that particular controller, the main broker, which is the leader broker's host and the port. So let me just get over here and type it. So it's going to be controller, the connection of that particular controller, comma error, and that's going to be kafka.dial. So the network is again TCP, and fmt.sprintf for formatting the string, and that's going to be the string, which is the host name and the port number. So how can we get the host and the port number of the leader broker, which is going to be located on the controller, right? So controller.host, comma, controller.port. Yes, we successfully created the controller connection. So again, the error. Yeah, so let me just move on to creating the topic. So before everything, let me just defer this connection, control con. After utilizing it, we are going to close this connection, which is a good practice. And then let me just create the topic. The topic name for our topic is going to be orders. And let me just create an error, and using the controller con connection, we are going to create the topic, create topics, and the Kafka topic config, and the name of the topic is going to be topic, and the number of partitions which are used for scalability inside the topic. So the number of partitions is going to be 1. And then the replication factor, which means how many times that particular partition can be replicated, which is going to be 1 here. And yeah, moving on, we just created the connection. Let me just go and paste it out, the if condition of the error over here, or else. Let me just fmt.println, println the thing, which is what we did. We created the topic orders. So that's it, guys. The created topics order one, we just created it. Moving on, what we are going to do is we are going to create a model. So from our previous project demo video, we used the order page, which is going to be requiring 2 things, which are the, I think, so the model page, we are going to require the product and the quantity here. So yeah, before that, let me just define the package order. And then in the order, I'm going to get the product and the string. And after that, I'm going to get the quantity, which is an int. So that's our model. So after that, what we are going to implement is we are going to implement the consumer.go. So for the consumer.go, let me just go here and make the package is order, and then the import function for the library. So what I'm going to use is I'm going to use context for creating the timeout sessions, and again the GitHub page, GitHub library, Kafka segmentio one, and then yeah, I'm going to paste it over here. And moving on, we are going to be requiring log, dfmt, and then encoding JSON file for sending, for encoding the details that we are going to get from the HTML page. So these are the libraries. So let me just create a function called consumer. And then inside the consumer, I'm going to create the Kafka reader. So let me just create a variable called reader for reading the input from the producer. So yeah, Kafka dot new reader, I think new reader, yeah. So and then we are going to create the reader config. For the reader config, we are going to implement the brokers. So the brokers is going to be an array, because from the architecture view, you can see that that can be multiple brokers, which can be running on multiple servers, right? So yeah, here we are going to create the broker, which is running on the localhost 29092. So yeah, so this is the broker, and the topic, which is subscribed by this consumer, is known as orders, which we have created in the create topic function. And then the group ID for this particular group is known as orders group. So why we require groups? Because there could be multiple orders which could be grouped into some kind of watches or dressers or some kind of other things like fruits and vegetables, or the kind of order groups. So for that, we are using group ID. So after that, we are going to defer the reader.close to gracefully close the reader after reading it, and then we are going to print ln the thing, which is Kafka. Let me just create a plus consumer listening. Yeah. So after that, for each of the message sent from the producer, we are going to read that. And so for reading it, we are going to use the reader.read message, and inside the message we are going to send the context. So context.background, yes. And then again, if the error is not equal to nil, we are just going to log.fatal the error. And then moving on, what we are going to do is we are going to create a variable called O, which is containing the model order. So we are going to unmarshal the value that is being sent by the producer. So the value is going to be stored in the message.value, and then the value is going to be message.value, and it's going to be stored in our model O variable we created here. So and then we are going to print ln the thing, which is order received, because the consumer received the order. So let me just make it a printf, and receive the order and the order quantity, the order name and the order quantity. Yeah, so this is going to be o.product, and that is going to be o.quantity. So that's it, guys. This is the consumer, what the function defines here is that it's going to be subscribed to the topic orders, and whatever messages that is going to be sent from the producer, it's going to be replicated into our consumer, and it's going to say order received. That's it, guys. Moving on to the producer. So let me just create the package order, and then inside for the producer, we're going to be requiring a couple of libraries, which is again most of the things we used in the consumer. So I'm just going to copy paste it here, but in we are going to be requiring time, because guys, this producer and consumer are going to be Go routines, so that we can easily manage each of these functions. Okay, So yeah, let me just create the function called producer, and inside the producer we are going to get the data from the order. So the order is going to be the parameter of this function. So yeah, we are going to get the order, the data, error, and then we're going to JSON dot Marshall, which is we are going to send the data. So the producer is going to be sending the data to the consumer. So we are going to be requiring this Marshall for converting that model into the JSON format. So yeah, again, if error not equal to nil, log dot fatal the error. God, if we are the error handling in Golang is so tough, but at the same time it's simpler. So yeah, the producer is going to be writer. It's going to be called the writer because it's going to write the events to the consumer, which is going to be reading from the producer. So this is going to be Kafka dot new writer. Yes. So it's going to have its own config. So the topic that we are going to use over here is orders. Yeah. So before that, this writer is also going to be working on a particular broker. That broker is going to be an array of string, and the address of that broker is going to be the same as that of the consumer, which is 29092. And yeah, that's it. We made the writer, and we are going to defer writer dot close. Yeah. So we made the writer, and we are going to wait for the consumer to get ready. So for that, we are going to sleep this go function for about a second. Yeah, so after that, what we are going to do is, the main purpose of writer is to write messages to the consumer. So we are going to be writing the messages to the consumer. We are the write messages function. So error equals writer dot write dot write message, and it's going to take the context, and then we are going to send it as a Kafka message. So guys, Kafka message is going to be like this. It's going to have a key and the value. So key is going to be defining the thing, which may be orders, inventory, or something like that, which is going to be the product name, or the product name, or the inventory name. It's up to you guys. You can create the key for that particular thing that we are sending to the consumer. So it's going to be a group of byte. And why it's byte? Because it's sending over to the internet, which is in JSON format. And yeah, so for the key, we are going to use the order.product as our key. And for the value, what we are going to be doing is that we are going to send the data that we marshaled before. Since it is marshaled, it is already in the JSON format, there is no need for converting into that array of bytes. So again, if the error is not equal to nil, we are just going to print it out. After that, we are going to print fmt.println. What we are going to print is, we are going to be printing producer sent a message. That's it. There's no need for a specification of message because it's handled by the consumer itself. So yes guys, that's the consumer, producer, and the create topic functions. So in the handler, we are going to implement just the basic things. So I think it will be okay if I copy paste that from my GitHub page. So yeah, in the handler function, we are going to be using the response writer and the request. So the order method, if it's a get method, we are going to serve the file from our index.html to our local host. And then if it's the post method, we are going to be calling the product producer, because in the post method, we are going to get the form value of the product and the form value of the quantity. And then we are going to assign it to our order model, which is product and the product and the quantity and the quantity. And then we are going to implement the go routine for producer. As I said before, you guys, the producer and the consumer are going to be go routines so that it can compute parallelly. So yeah, I think it's okay. That's our handler. Yeah, the handler function is implemented here. And that's it, guys. That's the internal for our Kafka ordering system. And then the consumer, I think everything is written perfectly. And then for the main function, what we are going to do is we are going to call all the things that we have did over here. So in the main function, we are going to be having the import, firstly the package main. Yeah, package main, and we are going to import the following things, which is net/http, and then the log one, and then again from the Kafka, I think it's Kafka Go, yeah, from Kafka Go internal, we're going to include the order. So that's it, guys. And the main function is going to be here. In the main function, we're going to firstly create the topic. Yeah, after creating the topic, we are going to implement the go routine for the consumer. After creating, which means we are implementing the consumer so that we can make it ready, the consumer, for the upcoming producers events, so that it can previously prepared for that. And then we are going to implement the http.handle function, and if it's root, it's gonna serve the order.order handler, and http.handle func. If it's the order endpoint, it's also going to be implementing the order and handler. So after that, we are going to print ln. Okay, what we are going to print here is we are going to be printing our server started at the localhost 8080. Yeah, and then we are going to be listen and serve the particular server http.listen and serve. What we are going to listen and serve here is on the 8080. We are going to listen and serve, and let me just create as now. Yes, guys, we made everything that we need for Kafka to work, but as I said before, we are going to be requiring a docker.compose file, docker-compose.yaml file. So let me just go to my GitHub page and copy paste this one here. Did I copy it? Yeah, I copied it. Yes. So let me just explain it to you guys. So the network here is KafkaNet, and the services that we're using is Zookeeper. So in recent Kafka versions, we are having Craft for the implementation of Kafka in recent versions, but in this particular project, we are implementing Zookeeper, and the version is 7.5.0. Make a note on this, guys. If you make this into latest, something like that, it will create you an error called TCP dial error, because I made that particular mistake a lot of time when I was learning about Kafka. So don't, if you want to implement the recent version of Kafka, then there is no need for Zookeeper. It just works well. current implements in Kafka. So the environment here is very important. So the environment for our Zookeeper client port is 2181, and for Kafka we are going to be requiring a couple of environment things. So firstly, the broker ID, which is 1. We are using only one particular broker here, and which is going to be connecting to the Zookeeper, and the advertised listeners, which means there are 2 advertised listeners here. One is listening on the port 9092 and the other one is 29092. So the Kafka 9092 is for the containers inside the Docker, and for communication between 2 containers which are running inside the Docker. And for the other advertised listener, which is on the local host, which is our current Mac, which is going to be interacting with the Kafka container, which is running on Docker. So it's going to be Mac and Docker interaction. And for the first thing, Kafka 9092, which is inside the Docker, so that's going to be interacting with the container, And it's going to be security protocol map, which is just a standard security protocol for Kafka. And the replication factor is 1. Auto create topics enable. If there is an error in creating topics, it will auto create the topics for us. So that's the Docker file. And for the index.html, I think you guys can easily understand it. We are just creating, let me just paste it over here. We are just creating the place order, the post method, in the forms. We're going to be naming it as quantity, place order, submit text, and that's it, guys. So fingers crossed. I think I didn't make any errors here. So let me just Docker compose up. So it's running, yeah. So I think here, let me just go to the localhost 8080. Yes, guys, see, look at that, it's working. So let me just run main.go. Oh, sorry, I just need to move to that folder, cmd/API. And from there, I'm going to run main.go. So yeah, the server started and everything is going well. Let me just zoom in for you guys. Let me just create a product called Jalebi, and the quantity is 3, and place order. The order is placed, and look at that. Look at how sweet order received Jalebi 3. That's how Kafka works, guys. That's how Kafka is implemented using Golang. So for another consumer, you can go to the internal consumer. You can just rename it as consumer 1, and you can create another consumer as consumer 2 below this. And let me just go to my GitHub repo, and here. So the extensible version of the project is over here, which is going to be microservice. Kafka is mainly involved using the microservice structure, so you guys can implement an order service with its own main.go, order handler, producer, consumer order, and everything for inside working of this. So that's it, guys. That's how Kafka using Go is implemented. And I also gave a brief description about how Kafka works. And if you find this video helpful, please like, share, and subscribe. And I guess this ends of the video. See you guys again in the next video. Bye bye.